We worked on just sine, cosine, and so here's the other four. Derivatives of the other basic trig functions. The derivative of tangent is secant squared. Derivative of cotangent is negative cosecant squared. Derivative of secant is secant tangent, and derivative of cosecant is negative cosecant cotangent. Now, we do have a quick little way that we can remember these by. If I write these up, they have to be written, of course, in a certain order. I write sine of theta, cosine of theta. And then underneath of it, I write secant, tangent. And then underneath that one, I write cosecant, cotangent. So nothing else. You can see you got sine, secant, cosecant, cosine, secant, cosecant, and then over here to the side, tangent, cotangent. Because the derivative of sine is cosine. Derivative of cosine, negative sine. So if you're going this way, it's positive. If you go this way, you change the sign. Secant, so if I'm going this way, the derivative of secant is secant tangent. If I go this way, the derivative of tangent is secant squared. And on this one, if I'm going this way, derivative of cosecant is cosecant cotangent. Derivative of cotangent is negative cosecant squared. Ooh, hey, I even missed a negative going this way. So I can just throw a negative on this guy here. Derivative of cosecant is negative cosecant cotangent. Derivative of cotangent is negative cosecant squared. So these are just a couple this is just a little trick that you can use to memorize these. And we come over here and notice tangent, secant squared. Tangent, secant squared. Cotangent, negative cosecant squared. Cotangent, negative cosecant squared. Secant is secant tangent, secant tangent. And cosecant is negative cosecant cotangent, cosecant, negative cosecant cotangent. Just a little trick. And hopefully you'll be able to use it to memorize these. So let's get into some examples and find out what happens. Find the equation of a line tangent to y equals x cosine of x at x equals 1. Now, we're not going to get a value at x equals 1, but if I evaluate y at 1, I'm going to get 1 cosine of 1. We're going to leave that alone until we get to the very end of the problem, and then we'll toss that value into the calculator. Now, here's one thing to keep in mind. Calculus is always done, can spell, calculus. You should always be in radians. Okay, so find the equation. Well, first I need the slope, so the derivative. So y prime equals, but this is a product rule. So here it is, u equals x, so u prime equals 1. V equals cosine of x, so v prime is negative sine of x. If you have to keep saying it, derivative sine is cosine, derivative cosine is negative sine. Got it. And then it's u prime v plus v prime u. So my derivative here is going to be cosine of x plus, and then go this way, that's a negative, negative x sine of x. So this is y prime, so y prime at 1 is going to be cosine of 1 minus sine of 1. Now, if you're trying to figure out what happened to the x, well, 1 times sine is still sine. Again, I'm not going to change these into actual numbers until I'm ready to actually write the whole problem out. So anyways, I'm going to write out the problem, and then I'm going to plug in the values. In calculus, 3 decimal places. Your answer must be correct the first 3 decimal places. I'm doing this so that I don't round incorrectly. So this is going to be y minus my y value, which is cosine at 1, equals my slope, which is here, which is cosine of 1 minus sine of 1 times x minus 1. I have everything here. This is what I'm looking for. You don't have a calculator, this is an acceptable answer, as long as you have everything in where it's supposed to be. But what I'm going to do now is I'm going to rewrite this with my decimal values with 3 decimal values. So cosine at 1 is 0.5403, so 0.540 equals, and I'm going to do these two together. So cosine of 1 minus sine of 1, I get a negative value of negative 0.301. Next value is 1, so it would stay at 1, times x minus 1. And there's our values. Now, you may not like working with that, but it's one of those that you need to make sure that you're not doing any kind of rounding boo-boos in the mix there. And so instead of that, here we go. Let me just write it out with the exact values, and I fix it in the end. But again, I do want to point out this is an acceptable answer if you do not have a calculator available to work with. Okay, so by the way, they put this into y equals mx plus b format, but they're showing the graph. There's your tangent line right there at 1, and there's your x cosine of x graph. And you can see this nice little line going through here. And at this point, we can even verify the slope being negative 3.012. Okay, so let's try another one. Find the equations of lines tangent and normal to this. Now, you guys had plenty of practice with the tangent and normal lines, but here's the big deal on this one is the fact that with trig, you get all these decimal values and you have to just be really careful, plus practice doing derivatives with trig. So on this one here, I have tangent of x over x. So this is going to be a quotient rule. U is going to be tangent of x. U prime equals secant squared. V equals x. V prime equals 1. And this is u prime v minus v prime u all over v squared. So we go into here, and so I get f prime of x, u prime v, so I have x secant squared of x minus v prime u, tangent of x, all over v squared, so x squared. And we need f prime of 2. So that's going to give us 2 secant squared of 2 minus tangent at 2 all over 4. That's our slope. Now we also need our y value, so we need f at 2, which is going to be tangent of 2 all over 2. Now, here's the one thing that I do get to point out to you is that this is the slope, but remember the reciprocal is going to, when I do the normal line, I'm just going to flip this guy over. So let's do our tangent line first. Our tangent line is going to be y minus my y value of tangent of 2 over 2 equals my slope, 2 secant squared of 2 minus tangent at 2 all over 4 times x minus 2. I know you guys are going, well, this is kind of monotonous. My biggest thing is I want to make sure that we don't get ugly answers or ugly fractions that you're fighting through now, that decimal values. So tangent of 2 divided by 2 gives us a value of negative, so this is going to become a plus, 1.0925. Now, if you're afraid of rounding, just throw that fourth decimal place in there. AP College Board doesn't mind if you don't round. They just look correct to the first 4 decimal places. Equals, and now I can plug this value in. Now, we have a secant squared, so you got to use that reciprocal idea, that secant is the reciprocal of cosine. So we have to look at it that way. So I'm going to do the cosine at 2 first. So cosine at 2 gives me this nice little negative number, but we want it squared because it's squared, which gives me a nice positive number. I need to multiply it by 2 times 2. So I have that number minus tangent at 2. Minus tangent at 2. Which gives us, oh, let's not forget to divide by 4. Divide by 4 gives us 0.6328 times x minus 2. Now I'm going to cheat a little bit here for the normal line, because in my calculator I have this full-fledged number in my calculator. So that's the only thing that's going to change for my number line, for my normal line. Y plus 1.0925 equals, but this time my slope's going to be negative. I'm just going to grab the reciprocal of this on my calculator, which is 1.5801 times x minus 2. So there's my tangent line. I lost my cursor. There you are. Okay, so here's my tangent line. I'm sorry, my normal line. And then this one here is my tangent line. Now keep in mind again, you don't have a calculator. This one's perfectly acceptable. Everything's in there the way it's supposed to be. And this is what I mean by you start getting the trig functions, you're no longer working with nice numbers. And again, I cannot express enough. Please remember, calculus is in 3 decimal places, correct to 3 decimal places. Okay, this one's giving us pi over 4, so this one's actually going to be a little bit nicer because it's a number we work with. So find the equations, line, normal, and tangent. This is just secant. So I could even go through here. Well, f of x is secant of x. So f of at pi over 4 is going to equal secant at pi over 4. And secant is the reciprocal of cosine. And cosine at pi over 4 is radical 2 over 2, which gives me my secant value of just radical 2. Cool. So we have my x and y value now. So I need my derivative, f prime of x. The derivative of secant is secant tangent. So this is secant of x, tangent of x. But I want to know what that value is at pi over 4. So I need secant of pi over 4 times tangent of pi over 4. And because our numbers are actually nice, I'm going to just go ahead and use them. We actually have fairly nice numbers. So but we haven't finished this one. Secant at pi over 4, we already did it. It's radical 2. And tangent at pi over 4 is 1. Now, this is where your trig is really going to show that you don't know your trig if you don't know it. And I'll tell you the same thing that my calculus teacher told me when I was in college when I told him, I don't know my trig. Take a class. Okay, well, that might not be feasible for everybody, but do get some tutoring or something on that one if to get it down. Main thing you need to know is that unit circle and your fundamental identities. After that, you can probably survive without not knowing much more about trig. Okay, let's finish our problem. Our tangent line. Y minus my y value is radical 2 equals my slope, which is radical 2, times x minus pi over 4. And you're done. You do not have to do anything more to that guy. And then my normal line is exactly the same. My slope is the only difference. Y minus radical 2 equals, the reciprocal of this is just going to be cosine, but it's going to be negative. Negative radical 2 over 2 times x minus pi over 4. Again, I got nice numbers out of these. And I know you're going, well, how do you know you're not going to get the other ones? These are unit circle values. You know your unit circle values, you get nice numbers to work with. So there are your answers. Now, if you're going, well, can you identify what you have to do first? Not so much what, it doesn't matter if you do this first or this first, but I can claim it. Find your y value, find your derivative, evaluate your derivative, and then write your lines, the equation of your lines, and you'll be done. Okay, now they're wanting us to do a second derivative on these. Well, at least on the last problem, we had the derivative secant. So y prime equals secant of x, tangent of x. And then you sit back going, dang it, now it's a product rule. So we do a product rule. U equals secant of x. So u prime is secant tangent. V equals tangent of x. V prime is secant squared. And this is product, so u prime v plus v prime u. So my second derivative, u prime v, so I have secant of x times tangent tangent, so tangent squared, plus, and then I multiply this way. And I have secant squared multiplied by secant is going to give me secant cubed of x. Okay, and we're done with this. Now, even if you factor out a secant of x, where you have tangent squared plus secant squared, unlike sine and cosine, they don't cancel each other out. So that is our answer. Our second derivative is secant of x, tangent squared of x plus secant cubed of x. And we're done. We're going to get a lot of practice with those quotient rules and the quotient and product rules on these. Okay, again, they want us to find the second derivative. So again, we have the product going on because they're using theta now. So u is going to be theta, it's the same as using x. So u prime is going to be 1. V equals tangent of x, and the derivative of tangent is secant squared. And again, u prime v plus v prime u. So go this way, y prime is going to be tangent of x plus, and multiplied this way, you get theta. Oh, I guess I need to stick with theta on these. No, theta or x. Okay, I'm going to pause for a minute. I'm going to let you know that old habits die hard. Okay, tangent of theta plus, multiply this way, we get theta secant squared of theta. That's only my first derivative. This is the guy that you got to be really careful with this time, because y double prime is going to start off easy. Derivative tangent is secant squared. But it's this guy, because definitely side work on this one. This is really theta times secant of theta times secant of theta. Ladies and gentlemen, you cannot use power rule on this one because it's attached to the chain rule, which you have not learned yet. So we are multiplying 3 things together. So we're going to have u, v, and w. So u is going to be theta, just like we had before. So u prime is 1. V is going to be secant of theta. So v prime secant squared. Well, guess what? W is the same as v, secant of theta. And w prime is going to be, I just noticed what I did there. No, that is not secant squared. If you're going, hey, wait a second, it's not secant squared, it's secant of theta, tangent of theta. And this one will have the same derivative, secant of theta, tangent of theta. But this time, instead of u prime v plus v prime u, you're going to have u prime vw plus v prime uw plus w prime uv. So anyways, each derivative with the other 2 functions. So u prime times these 2 is going to give me another secant squared. Then we'll place these 2 together. And then v prime, this guy here, times these 2 is going to give me secant squared tangent theta plus theta secant squared of theta tangent of theta. And then the last one, w prime times these 2 is going to give me this thing again. So instead of writing that out, well, I'll just do it. Plus theta secant squared of theta tangent of theta. A lot. That's what we have. Now we can do some cleanup here. Y double prime equals, notice I have this guy twice. Too bad I didn't write down 2. My eraser. So I have 2 secant squared of theta plus 2 secant squared of theta tangent of theta. And again, factoring it out isn't going to make a whole big of difference. Common factor is negative is 2 secant squared. You know, probably the best part about that would be is if you were going to find the third derivative, move the secants away from the tangent. But there you guys have it on this one here. A lot going on that one. And so this one is going to be one of those, oops, pause. This video is getting a little bit long, but I think we're almost done. Oh, look, we're done. All right. So good luck on these, and yeah, good luck.